Hey there, all you flat earth and round earthers. I'd like to just give a shout out to both of you. First of all, round earthers, I used to be one of you, and I don't blame you for the mindsets that you hold, as I understand how deeply ingrained they are. One thing I do want to say is that I like to argue with people and to discuss with people that have good arguments that are well thought out. There are very few round earthers that have good, well thought out arguments. Most of the arguments that you hear from round earthers are something like, "It's the 21st century, the earth is round, you dumbass," instead of well thought out arguments to address the very valid points that flat earthers are bringing forward today. Many of these points are hard to argue with, except by bringing forth or regurgitating things that really don't make a lot of sense, according to round earth beliefs. What I am about to present to you is a simple argument to establish that perhaps the earth is not flat. It is not a solid, perfect argument for a flat earth, but it is an argument and a discussion point to make one question the validity of a heliocentric model of our solar system. And I encourage round earthers to bring forth arguments to look at this point that I am making. I welcome that, but please let them be intelligent arguments and not the dumbass arguments that I brought forth before. And I will say this, by discrediting the heliocentric model of our solar system, I do tend to default then into the flat earth model, for good reason. So let's take a look at this simple point that should make you at least question what's going on here. The generally held round earth view is that summer and winter is created by the angle that the sun aspects to the earth. So as we see on the left side of this image, the summer is created when the tilt of the earth, which is at 23.5 degrees, is pointed towards the sun in the northern hemisphere. So there we will have northern hemisphere summer and southern hemisphere winter. And on the right side of this image, where the tilt is away in the north, we have winter in the north, and in the southern hemisphere we have the summer. So this is all based on the idea of what angle the sun is making to the earth. And by the way, in case you didn't know, the belief in round earth is that when the sun is in this position on the right, which is the winter in the northern hemisphere, the sun is actually 5 million kilometers closer to the earth than in the position on the left side of the image when it is northern hemisphere summer. The sun is actually 5 million kilometers farther away. You really have to put a lot of faith in the idea that it's the angle of the sun to the earth that determines the heat of the summer, because the earth, according to the round earth belief, is actually 5 million kilometers farther, which doesn't make a heck of a lot of resonant sense when you think about it. Neither will it make sense what I establish with you soon, and it will discredit this heliocentric round earth model. Here in this image we see that on June 21st, the angle in the northern hemisphere is going to be much higher than on December 21st, when, as we looked at in the other image, the sun is much more direct in the northern hemisphere on June 21st, because the tilt, this is the idea of round Earth, is towards the sun, and in the south the tilt is towards the sun on December 21st the most, and that will be the most direct angles that we have. So that's the round Earth idea. And I asked myself, okay, so if that's the case, then what if we compared the angles of the sun on December 21st and June 21st to make them the same? I used this chart to try to figure out at what time on June 21st would the angle of the sun be the same as on December 21st, when the sun is at its summit, at its highest point in the northern hemisphere, because that's the point that we can compare when the sun would be hottest on December 21st to the time of day on June 21st, when the sun is at the same exact angle as on December 21st. The sun at the same angle on those two different days should be roughly the same in temperature, in impact of thermal heat on the Earth, because we're on a round ball. And if we see the sun in the sky at the same angle, the impact of the sun should be the same, if not hotter, on December 21st in the northern hemisphere, because it is 5 million kilometers closer. Is that what we get? Actually, it's not by a long shot. Now here, this is a very rough schematic that looks like at around 5 p.m. the sun will be at the same angle, but I used the program Stellarium to get a very precise time, and that time ends up being at 6:29 p.m. on June 21st. Stellarium is a great program because you can determine the exact time of day when the sun is at the highest angle. And on this day, December 21st, that time is just before noon at 11:53 a.m. when it reaches an angle of 21 degrees and 10 minutes. And so I then went to June 21st to find what time exactly the sun was at that same angle. And please note at this day that the sun is 147 million kilometers away from the Earth. Now here we are on June 21st, when the sun is at the very same angle as it is on December 21st at 11:53 a.m. Here it is at 6:29 p.m. that the sun makes the same angle. And note, the distance of the sun to the Earth is 152 million kilometers, 5 million kilometers further away than on December 21st. So isolating that factor, having the same angle on those 2 days, since we are on, this according to the round Earth theory, since we're on a ball, if the sun is sitting up at that same angle, then there should be no difference in the impact of the thermal power of the sun at those 2 times, and if anything, the sun should be hotter and felt hotter on December 21st, since it is 5 million kilometers closer. That is the idea. But now the million-dollar question is that the case? Is the sun felt to be hotter on December 21st, or the same, at least, as on June 21st at 6:29 p.m.? And the answer is definitely not. Every single person that I ask clearly answers that the sun is definitely hotter at 6:29 p.m. on June 21st, according to their awareness. And I think it is an undeniable fact that that is so. So what does it tell us? Well, it is definitely compromising the round Earth heliocentric model. One only has to be honest with oneself to see this. In order to look at this question fairly and accurately, we have to be looking from the same place on Earth. Compare December 21st and June 21st, when the sun is at the same angle, from the same city in the northern hemisphere. Also, it's important for the day to have no clouds, so that the clouds do not inhibit this experiment. Everyone that I have spoken to about this and asked about this to compare the sun's heat, the thermal impact, comparing these two times and dates, no one even hesitates. They say, of course, the sun is much hotter, significantly hotter, on June the 21st at 6:30 p.m. Do a little experiment now, very easy experiment. Light a candle and put your hand as close as you can without burning yourself. Feel the heat. Then slowly withdraw your hand from the candle. What do you notice? A very simple phenomena, that the farther you move your hand from the candle, the less heat you feel. And this is what's happening here with the sun. That the thermal impact of the sun is a matter of distance, not just angle. Of course, when the sun is directly overhead in the summer, we do feel a stronger impact. But a lot of that also has to do with the distance that the sun is to us. In the summer, it's closer in the northern hemisphere in the summer because the sun is moving into the position over the Tropic of Cancer, which is much closer to the northern hemisphere than when the sun moves into the position of the Tropic of Capricorn during the northern hemisphere's winter. It is the distance of the sun that determines its heat, not just the angle. As I believe I have just established by comparing the same angles when the sun is over the Tropic of Capricorn on December 21st and when it is over the Tropic of Cancer on June 21st. And please forgive me the misnomers of calling the northern hemisphere because it is not a half a sphere. It is the area most close to the North Pole, which is in the center of the flat Earth. This also makes sense of the ice wall that we perceive in the flat Earth model that is called Antarctica, because the sun only has a certain area of effect for its heat to have an impact, and beyond that effect there is cold and thus ice, and also why we have our winter in the north closest to the central North Pole. When the sun is at the Tropic of Capricorn, it only has a certain area, only has a certain distance of effect, like in the experiment that you just experienced, putting your hand close to the heat of the flame. It doesn't carry forever. There is not this magical ray of light moving through space that when it finally impacts Earth, suddenly it has this heat effect. That's not how it works or how we observe it. In my next video, I will attempt to perform some form of quantifiable test to demonstrate the increased solar power on June 21st at the same angle as on December 21st. And I will use my concave mirror and measure the amount of time that it takes to light a cedar shingle, which is not a perfect experiment, but it'll give us a general idea if there is in fact more solar power there in terms of heat, and it's not just this subjective feeling that we have that the sun is in fact hotter on that day. What would also be very helpful is to have some data from people who work with solar thermal power to get some data about the amount of power in the sun at the different times of the year. I haven't been able to find this data, so if any of you out there have it, please do attach a reference or a link to this video below. Thank you. And just to note the difference between solar thermal power, that's the heat of the sun that generates power, versus the standard solar paneling that we tend to see on the rooftops and in the fields, which is collecting electricity and converting the solar light to electricity with photovoltaic cells. This is different from solar thermal power. So I thank you very much for watching this video. In my next video, I will demonstrate and show my calculations in approximately determining the distance of the sun to an observer's point on Earth in the northern hemisphere, comparing the distance on December 21st to June 21st, and demonstrating that the sun is actually hotter on June 21st because it's closer, and not to do with the angle as I've demonstrated in this video. Alright, so hope everyone has a wonderful day, and thank you for listening.